Now that we know the definition of a logarithm, let's look at some of the properties of logarithms. The first is that log base a of 1 is going to equal 0. Any base of a log of 1 is going to be equal to 0. And the rationale for that is if I convert this to exponential form, a to the 0 is equal to 1. Anything raised to the 0 power is going to be equal 1. Anything that's larger than 0 is going to be equal to 1. And that's one of the pieces of a logarithmic function, that the log has to be greater than 0. So this is going to work for everything that a log is defined for. The second one, log base a of a is equal to 1. If I convert that to exponential form, I see a to the first is equal to a. Anything raised to the first power is going to be the same as the base, so that's a true statement. The third one that we have here is the inverse property. We've already stated that logs and exponents are inverses of each other. So in terms of the mathematics, it looks like stuff is just going to cancel out. Here, log base a of x is equal to x. The log base a and a cancel out, which leaves us just x left over. And here, a raised to the log base a of x is equal to x. A and log base a cancel out. And the reason for that is what you learned back in chapter 1, where if I compose two functions, and those functions are inverses of each other, I am going to be left with the identity, which is going to be x. And I can do the same thing in the other direction. F inverse of f of x is going to be equal to the identity. And if I take f of x equals a to the x and f inverse of x as being log base a of x, I will see that that holds true. If I compose those two values together, I will see I'll end up with just x. The final property then is the one-to-one property that says if I have logs of the same base and I've got one value, I know that the other value has to be equal. So this is going to be the one-to-one property. We've got a special type of logarithm, the natural logarithm, that is directly related to e. And we write a natural logarithm as ln. But ln is just the exact same thing as log base e. So if you get confused of what the ln notation is, in your mind think it's log base e. So I can apply my same definitions for the natural logarithmic function that I had for the exponential. And that's if y is equal to the ln of x, I can convert that to exponential form by saying x equals e to the y. Once again, if you get confused by that notation, realize here that this y equals ln of x is the same thing as y equals log base e of x. And if I look at it from that perspective, I can see the base of my log is the same as the base of the exponent. The answer to the log is just my exponent, which is there. And the big key here is that the ln and e are inverses of each other. They are going to cancel each other out. So the four properties of natural logarithms are the same as the properties for logarithms. The natural log of 1 is equal to 0, and once again I could look at that as log base e of 1 is equal to 0. E to the 0 is equal to 1 because anything to the 0 power is equal to 1. And I could go through the exact same rationale with these properties that I did up here at the top. Once again, we're going to have the inverse property, and I'm going to have the one-to-one property. So a couple of examples that we've got here. Log base 2 of 2 raised to the 5x. That's our inverse property that we're applying. So the log base 2 and 2 are really going to cancel each other out, which is going to leave us with just a 5x. 4 raised to the log base 4 of 53. Once again, that's the inverse property. The 4 and the log base 4 are inverses of each other, so we're left with 53. The third example, log base 4 of 43 equals log base 2 of x. Since I've got the same logs right here, I can use the one-to-one property that says 43 is equal to x. The fourth example, e to the ln of 67. E and ln, once again, are inverses of each other. So I'm going to be left with 67. The fifth example, we know e to the 0 is equal to 1. So really I'm trying to find 45 times the ln of 1. And we know from our properties up here that the ln of 1 is equal to 0. So 45 times 0 is going to give me 0. And then finally, the ln of e, when nothing is written in the exponent, it's understood to be an exponent of 1. So ln and e cancel each other out, which is going to leave me with 1.